Hi everyone, during my previous session we covered models with autocorrelation. That means that we use AR or autoregressive and MA moving averages. Yes, autoregressive meaning lags, yes, from previous observations in order to fix the problem of autocorrelation, and moving averages in order to smooth the time series at the same time. So now in this video clip we are going to go a little bit beyond, and we are going to start including external information, meaning that apart from the same variable, we have been working just on the same variable using previous observations and mathematical estimations in order to forecast. Now we are going to add new variables to our models. So from now on we are going to cover this type of models, and I hope that you are going to enjoy them. So let's go to my full desktop. Here we have the chapter 7. So this is what we are covering now. Chapter 7 is about regressions models with autocorrelation and ARIMA, but also we are going to cover, of course, external information. This is chapter 7. Okay, so I have here, so including external information, I have this picture here because we want what we want to do is to like have different perspectives from our data. So that is why we are using different type of if you want, glasses to see the reality. So that is why external information is like together with this picture here. Right, so we have in general irregular patterns that are explained and unexplained in our data. Sometimes these patterns need to be cleaned in the data before we can start like forecasting or analyzing the data. We need to make sure that we are not actually changing the data when, for instance, we have outliers. Outliers is a data in our time series that are very high or very low, or that simply they like stand out because of their peaks. They are like very far away from what probably will be sensible to be. But sometimes we have outliers because we have severe shocks, the Great Depression, the Great Financial Crisis, the dot-com, the pandemic, whatever it is. So as you know, outliers are omnipresent in time series, especially in economics. But sometimes they occur because there are just problems in the data. Yes, for instance, there was just a simple well, problem like in the markets. For instance, if you are analyzing a market, there was I do not know, a microstructure problem, that meaning that the data was very thin. There was not very much liquidity, cash in the market for the market to work perfectly. So then you have like a jump down in your data or a jump up in your data, because as liquidity goes, it gets very volatile. So apart from that, we have special events such as holiday sporting events. So that is why we have here the Olympics. So we can add those special contents to our data sets. Now we can use dummy variables. I recall that dummy variables are simply zeros and one when the event is happening, zero when the event is not happening. So in that you will be able to start thinking on doing event studies. Yes, so for instance, zeros when, for instance, the pandemic started, ones when the pandemic is on, zeros before the vaccine was developed, one after the vaccine was developed, and so on and so far. You can actually create many dummy variables and to get to know that thing that will actually help a lot the data. Yes. All right. We have as well interventions in the economy. So that means that apart from these special events, we have actually policymakers making interventions in the economy. So you will see that we have the Central Bank of England increasing quantitative easing, funding the economy, buying short-run bonds and selling them in the long-run market. We have interventions from the government, so they trying to furlough people to try to cope with the crisis, or trying to build more infrastructure in order to carry on conducting supply side policies to help employment from the other side of the market. And obviously that this can be included as well when we have this framework of regression or linear regression or multiple linear regression, if you want, with this type of interventions. So what are the solutions for these problems of outliers, special events, or interventions? The solutions are as follows: remove unusual periods from the model, so taking out the outliers, for instance. Obviously that has a science. If you remove outliers from your time series, I think you need to explain why. Yes, I think it's more common to smooth the series by using moving averages. So we did that when we studied, for instance, or predicted the coronavirus lockdown last time back in December. And yes, I think if you are going to remove data from your time series, I think you need to explain very well why and what was the criteria to remove the data in your paper or in your project. All right, we can model the series separately, so we can, for instance, conduct two regressions on the error, so we are able to model like in different contexts or in different regressions our data sets. We can model as well with dummy variables, using dummy variables to account for interventions in the economy and special events is sometimes a good way to go. Sometimes when you have numerical interventions, so you know the figures, you are able as well to put them in there rather than using dummy variables with zeros and one. And I think that these are the solutions for these three problems that we have in here. Right, so what if the pattern changes? So right, so we have obviously patterns in the economy. I think if you have been investing in Forex or in the share market or in the bond market, you will know that there are certain patterns, and there are some times in which we have breaks on these global patterns, or global and local patterns in the time series. And we need to get to know what if a pattern changes. So do we know when it changes? I think that will be probably something very important in order to get to know when to enter or exit a trade in the markets, or when to try to explain the fundamentals in the economy. Yes, we want to know when the pattern is going to change in order to prepare our economy to get the like a beta performance. Yes, if you want to find, or if you want some Keynesian wise methodologies or policies, or monetary policies, if what you want to do is to control the economy through monetary policy. So we have then in this case separate models and external predictors, and in doing that we are going to be able to try to cope with the problem of pattern changes. Here we have Indian Railways in our picture, and we have as well Kingfisher, which are like in the transport sector. Obviously we want to get to know where the pattern changes and how we can forecast beta, for instance, sales for these two companies. So some methods such as linear regression, as well as logistic regression and neural networks, these three methods we are going to cover during this course, allow the inclusion of external information in form of predictors. So for instance, you have here a variable that is class attendance. I could perfectly change this by y. Yes, equals beta 0 plus, these are coefficients. This is the intercept. Yes, this coefficient beta 0 is the intercept. Beta 1 is the coefficient or the weight for this class attendance. As you can see, class attendance was actually y as well, but class attendance in the previous period. So the present period depends on the previous period, and this we can carry on, for instance, adding more and more variables. Here I have a different one, so I will put to this one an x, yes, variable, which is in times t, yes, and an error epsilon. So as you can see, we can carry on adding, including external information that might help the solution of the model. So including external information can include as predictors, um, many variables. So we need to make sure is that the predictors are available at the time of prediction. I think that will be for obvious reasons. So in paper you can run any regression if you want, but if the data in the reality, in the practical reality is not in time for you to get to know, well, I think that would be a very probably less important estimation technique. Yes, you would like to work with the information that is available today and try to carry doing like a estimation or like a regression model that are actually accounting for the time lags that occur when we do not know the information from the markets. So here we have an example in the NBC internet example. We found that TV ads have an impact for about 6 months, and a simple but good model would be, this is the sales, then yes, and we have that the sales are the functions of sales in times t minus 1, time t minus 2, time etc. up until t time t minus 6. Yes, and here we have as well all the ads here, as you can see, in time t minus 1. This is the square root of the variable, yes, and up until t minus 6, yes, also t minus 1, t minus 2, t minus 3, t minus 4, t minus 5, and t minus 6. So you got this regression, and with this, as you can see, if our in the reality I can have data about the ads, fair enough, I will be able to run the regression. If, for instance, I do not have in time t the information of t minus 1, say previous week or the previous day, I think it's better not to use this regression, because obviously it is going to be like probably theoretically worth, but it will be probably worthless if you are conducting a regression for a business, because you will not be able to find this information. Right, so you can find more information about this example in analyticbridge.com. It's actually an interesting place to find things about these topics. Yes, you will be able to find enterprise analytical trends, learning delivers a competitive advantage, many other blog posts, and advices for use cases in data science, and examples coming from many places in order to tackle the problem. I think here we have, for instance, coronavirus effect on algorithm validity, and many other interesting sources of information related to data science or forecasting. Okay, so we have an issue then when we include external information. The issue number 1 will be the form of predictors. So we are, we are able, apart from using lagged predictors, we can actually use forecasted predictors, right? That makes sense. So imagine that we are forecasting airfare, yes, so you will be able then to use the gas price in the previous time, but also you will be able to use as a predictor the gas price in the future, right? So you predict the future. Let's say you predict the future today, that is going to be certain. So in the time t plus 1 in the future, you will use your prediction in order to try to forecast the airfare. So you will have two ways in which you can improve your presentations here, by using lagged or forecasted variables. Both make sense. This one makes sense from the point of view of rational expectations, yes, and this one make well, this, both of them are actually in part make sense from the point of view of rational expectations. But when you have rational expectations, usually you use all available information at the moment when you are estimating or forming your expectations. Yes, and so you can add, apart from lagged and forecasted variables, many other variables, such as in the way we explain with external information. So number two, another issue that we have is the issues of training and validation periods for your presentations. For instance, you will have this problem. You will be able to choose data. I have advised you to use like a timeline for your time series, so you will be able to identify key dates, yes, where you are able to identify like key shocks in the economy, and you will be able to choose those key dates in order to make the partitions of your data set. Obviously here we are doing out of the sample forecasting, so we make partitions, one called training period, another one called validation period. We use the training period to train our forecasting techniques and to choose the best forecasting techniques, and we do that just by comparing our validation period with our forecasts. So the data availability and the forecast horizon, that is something that we need to take into account. We must account for lag time in obtaining data. So for instance, here we have that we can use them the available at the time of prediction. This variable needs to be there in order for us to be able to forecast the data. So obviously this relates to this training and validation period. As I said before, we make this partition first. We have done this many times in our labs. If you do not understand this, I will advise you to follow my handbook, my lab handbook, which is very detailed and has pictures and everything, and you will be able to make the partitions using R. What we do is to run regressions here, estimation techniques, and then we choose one forecast, compare the validation periods of all of them. We try to look at the forecast that has errors closer to zero, because obviously it's going to be closer to this validation period. And then after we choose the best forecast, we are able to come here, use the whole data set, and forecast the future using that estimation technique that is the best. So here we have an example of predicting the future with social media. Particularly important, apart from this example, is the fact that we are able to predict flus and like even pandemics and and many other like virus going around, when we, for instance, use Google or Google in order to try to find the time in which people start typing for remedies, or start typing the keywords in Google in order to find solutions for certain flu virus or coronavirus, whatever it is. So we are able then to predict the future with social media. I think you have seen many cases, such as Cambridge Analytica, in which actually, apart from using social media, we are like bombarding certain targeted people in order to try either to change their minds. Some probably very unethical politicians are trying to radicalize the thoughts of their party members, so they start being bombarded by this type of news. Probably you have seen that you start seeing adverts in your phone about things that actually you were looking for on internet, or that you were talking about with someone. So that makes you think sometimes that someone is listening at you, or looking at what you are doing, and forecasting what is the best ad for you. So as you can see, all of this is done through the same concepts that we are using here. Is just forecasting, is just targeting objectives, minimizing the errors in order to get better results. So I have here this actual article here. It would be great if you have a look at this. It's predicting the future with social media. A very interesting source in order to get like some more insight about this. You will see very interesting notes here. The question how social media content can be used to predict real world outcomes. Yes, so we have here the topics, what they discover, some literature review. They use, for instance, a Twitter search app, API, which is the way in which you can pull information from Twitter or from Facebook or from, this is like a protocol, yes, and then download the tweets from many people referring to 24 different movies. These are the results, and obviously with those results from those movies, they will be able to um, calculate, for instance, this is the release, and they are able to calculate what are the impacts of these uh, films in the reality. Yes, so it's a very interesting research using social media just to analyze what is the impact of certain titles, certain films that are in the markets, what is the right time to, for instance, release the films, and well, I will advise you to read this as a homework. Okay, so here there is a question. We already covered this on the previous slide. So predicting box office revenues for movies using the data from Twitter. So that is fine. We already saw these tweets per authors and days on the previous slide. And here then we have an example. This is the daily tweet rate. Yes, the R daily tweet rate, as you can see, is actually a very simple regression in which they are using lags. Yes, probably a different variable here, but that's all. Apart from that is AR, yes, AR of order 7, yes, and then they are using TSS as a number of theaters as an additional variable. So in all data, they use data prior to the release to predict the box office for the opening weekend. And since historical information on twins are not available retrospectively, we were able to use data on only the movies we have collected, right? So this is the way in which you will be able to find solutions. That the uses of these forecasting techniques are endless. I will say is the future. You will be able to participate in the market to calculate or make robots like calculate, for instance, this type of problems, or is for macroeconomics, microeconomics, finance, etc. Okay, so in brief, make sure that the forecasting methods in your project use external information in a valid fashion. You must define the required forecasting horizon. You need to determine data availability and timing and evaluate performance accordingly. All right, guys. So that is for today. This is the lecture for week 18, and then I think we will be able to run an example next week on week 19 lab. So all these lectures are linked to the next week seminar. Yes, because we want all the labs to follow the lectures and not the other way around. Okay, guys, have a nice rest of the day.